Good morning, folks. It's 2:58 a.m. I'm a little bit under the weather today, but I'll probably be back tomorrow. I'm just fatigued from taking care of people. Anyway, let's do the note for Chapter 9, Section 1. We will get a pretty good sized packet to do as homework for this unit, so there's not a lot of practice quiz. Please ask me any question when I come back tomorrow on Tuesday. So, in real life, to make any chemical reaction happens, and you don't want to have any waste or any financial burden, or in some cases legally you cannot dispose of chemical if you have too much waste. You want to make sure your calculation and prediction is done correctly, and with that we do measure matter in real life in volume or with mass when we put them into a reactor for the reaction to happen, whether it's in big company like 3M or in small food company that makes chemical and herbal natural remedy. So let's go. The number that you need to know is going to be Avogadro number. It represents a quantity of material, and that's usually related to atoms, molecule, or formula unit, basically particle. And we call this unit the mole unit because the mole is kind of like the word a dozen. Um, it just represents an amount of physically real material. With that again, atoms, molecule, formula unit if it's ionic. But it was created a while ago when people realized that if we want to have accurate estimation of ratio, like 2 H's to an O in the molecule of water, or one sodium and one chlorine in the formula unit of salt, they needed something to be able to compare and contrast and come up with formula correctly. So that's where the mole comes from. Please write down this number and memorize it as best as you can. We are only going to use 6.022 times 10 to the 23rd. Some places might go a little bit farther than that if they were doing a calculation in real life to have a high accuracy. But for 99% of most situations, we are only going to go to 3 decimal place, 6.022. The time 10 to the 23rd is going to be the same for anyone around the planet. So write this down, memorize it as soon as you can. You're going to be basing the whole chapter partially on this, so make sure you know it. Today you should already have a calculator. You can use your Chromebook as a calculator for now, but on your test you're going to need a calculator, and it'll be just faster than clicking on the one online. So just bring a calculator. Here is just a basic guide on how to do some calculation for this first section. Go ahead and write it down. Pretty straightforward. You're going to see me doing it in a little bit. The only difference is, for me, I am going to put a parenthesis instead of just the multiplication sign. So you will see that in my example coming up. This is just a picture I got from Google. You're welcome to write this down, but please note, please add that 2. So 6.022, not 6.02 for all class application, because we're in high school now, and we are going to do a little bit higher level accuracy since it's 2024. 6.02 was used back in the 80s, 90s for high school, but honestly, most colleges and university will tell you 6.022 is the minimum. So go and write this down. So we're going to calculate this example. Calculate the number of mole. So we make sure we box what we're trying to find, and we underline what we're given. Okay. Once again, if it's an element, it's an atom. If it's a covalent compound, it's a molecule. If it's ionic, it's formula unit. They all represent the same thing, which is a number of particle. So with that, always write down what you're given. That's step number 1. And please write down the unit, because this is unit conversion or dimensional analysis without the unit is useless. Draw your conversion bracket. Please make this a little bit bigger than a tiny one the size of your finger. You have plenty of paper. The unit that you start with goes opposite, so that way it can cancel in height. So atom is on top. We're going to put atom in the bottom. And the unit that we're going to is mole, so we can put mole on top. Please know that mole can go to anything: atom, molecule, gram, liter, any other unit. So any unit can go straight to mole. And please know that in one conversion bracket, you only can have one change. So here we're going from atom of iron to mole of iron. That is one change. We can do that. The number in front of mole will always be 1 for this chapter. We're saying 1 dozen is 12. So 1 mole is going to be Avogadro number, which is 6.022 times 10 to the 23rd. Cancel out the atom. So the only unit we have left is mole. We grab a calculator and we punch it out. 9.22 times 10 to the 23rd divided by, because 6.022 is in the bottom, we divide times 10 to the 23rd, and my calculator tells me roughly 1.531. Okay, so since we have 3 significant figures at the top or in the front, we only need to keep 3, so we can just take away the 1. We don't need that. So 1.53 mole is the most accurate answer, not because it's long, because it's the correct number of sig fig. Yes, that's coming back. Okay, so read this question. We're looking for how many formula unit. We don't care what chemical it is because it's the same chemical. HNO3 is nitric acid. So we're not converting the chemical, we're just converting the unit. We underline what we're given. So with that, step number 1, write down what you're given. Try your conversion bracket. The unit that you start with go in the opposite height. So we started with mole on top. We put mole in the bottom. And once again, mole can go to anything. So we can go to formula unit. And the number in front of mole again is always 1 for this chapter. 1. The number in front of atoms, molecule, or formula unit will be Avogadro's number, which is 6.022 times 10 to the 23rd. Cancel it out, and you reach your goal. So take 0.025 times 6.022, and I get 1.5055. But since I only have 2 sig fig at the beginning, I don't need to keep all of it, so I just go 1.5 instead of 1.5055 times 10 to the 23rd. But the 23rd we still do, because those are 0. They don't count for sig fig, but we're still saying that this is a huge number, and that's the correct answer. So a student was told he has 6.51 times 10 to the 24th atom of gold. How many mole of gold is that? So once again, write down what you're given. And the unit. Do your conversion bracket. We start with atom on top, so we put atoms in the bottom. We go into mole, and the number in front of mole is 1. The number in front of atoms or molecule or formula unit is Avogadro's number again. Cross that out and punch it out. So here we have 6.51 times 10 to the 24th divided by 6.022 times 10 to the 23rd, because this is in the bottom, and we end up with 10.8. And it's 10.8103 blah blah blah, but once again I start with 3 sig fig. I'm going to keep 3 sig fig. And the unit that's left is mole. So pretend if this was not an atoms or molecule. If you have $1 billion, 1 times 10 to the 9. How many mole of dollar would that be? So 1.0 times 10 to the 9 dollar. I was just going to call it dough for conversion bracket. Dollar go in the bottom, or dough. You can use a dollar sign if you want. And then mole on top. Once again, the number in front of mole will always be 1. And the number in front of any unit that we're talking in relation to mole, in this case, dollar for fun, instead of atoms, molecule, formula, unit, will still be Avogadro's number. And punch it out. So 1 times 10 to the 9 divided by 6.022 times 10 to the 23rd, and I end up with a small number. I get 1.66, so I'm just going to round it to 1.7 times 10 to the negative 15 mole. Okay, so a billion is small. We're still 0.000000000 all the way up, away from 1. So a billion is still a very small number when we're comparing it to the mole or Avogadro's number. Anyway, to stop here for today, and if you have any question, feel free to ask me tomorrow. I will have your test score probably in tomorrow. Also, I'm still grading. I just got done with the lab report last night, and the test I got 6 hours done, and I will probably be spending another 5 hours today, 4 hours today, grading the homework for the freshmen and your second test. With that, have a good day.